We're going to solve systems of linear equations. And because this is an introduction to that concept, I just want to show you some pictures. So first of all, let's talk about what a linear equation is. Linear equation, those are lines when they're graphed. So let's put a line up here. Just something like that. And I'm going to label that L1. So there's my line 1. Now a system of linear equations means there's more than one. So here, let's just draw another one. And it doesn't matter where I put it. Let's put it right there. You have to pretend that's straight. And we're going to call that L2. And I don't know why, but we usually use little cursive L's. And the solving part of solving a system of linear equation is answering the question, where do these lines cross? So here, this is where our lines cross. And so let's just make a number up. Let's just pretend in this problem that was 2, 0. I don't know if that's it, but because I just made this up. But that's the solution then, okay? So where do the lines cross is a point. Where do the lines cross? That's a point. Now, is there any other way you could draw two lines and have them maybe not cross? So, of course, if I take two lines and make them parallel, they don't cross at all. Well, what is it about these lines? Well, these lines have the same slope. We already know that's how parallel lines work. Same m, but we'll go ahead and write slope. Okay, so answer the question, where do these two lines cross? And you're going to tell me, they don't. No, they don't. So there's no solution in this. Okay, you can also write it as a circle with a slash. That's the null set, the set which is empty. It contains nothing. Okay, now there's one more case that happens, and that is they give you an equation. And now let's go ahead and start to use some actual equations so you can see this. What if I gave you y equals 2x plus 1? And we graphed that here, okay? We'll call that L1. Then I go like this for L2. I give you what is the exact same line. I'm just going to multiply it by 2 so you can see it's the same line, right? You would divide both sides by 2 and you'd be back up there. But algebraically, they do something and you don't immediately notice it. So you go to graph it and then you find out this. Squeak, 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 squeak. Okay, not great. But what you find out is that L1 was equal to L2. Now, answer the question. Where do these lines overlap? Do they overlap right here? Do they overlap right here? Here, 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 right? They overlap everywhere. Well, everywhere. Do they overlap right here? No, they don't overlap everywhere. It's not a one-dimension problem where it's just like the numbers, you know, negative infinity to infinity. Each of these are ordered pairs. So when we had one-dimension problems and you had some funniness, it was no solution or all real numbers. But when you have a two-dimension meaning you have an x and a y, and the lines, these equations are the same, when you get this, the answer is not all real numbers. These aren't even real numbers. What are we playing around with? We're playing around with points, ordered pairs, x comma y's. And is the answer all ordered pairs? It does not cover this entire plane. It just is the points on this line. So in this case, the solution is all the ordered pairs that lie on this line. And now there are infinite many of them, but that is not the answer. You need to say it's all the points that lie on this line. So if I write it out in words, it's all the points on L1, which is equal to L2, which is the equation y equals 2x plus 1. Now look, to be clear, I'm boxing it in. That's the answer to this problem. Not infinite solutions, not all real numbers. It's the points on this line because they gave you the same line. Okay, so to overview, we've got ones where the answer is a point. We've got answers where there's no solution, and we have answers where the answer is an equation. Now, then we'll go over the various methods for solving this.